For this question on linear law, the two parts are actually not related. So part A is more like testing your idea of a linear law. So if you are a bit shaky about the concept of on linear law, uh, you will have some issue with part A. If your concept of linear law is very clear, it's a very direct question. So they simply give you a formula. Okay, so they did explain what's the formula about. So the formula is about the stopping distance. So the stopping distance is related to the traveling speed. So then for that, and then they collect different values of d and speed. And then, so the question is asking you, how would drawing a straight line to represent the formula, how would you go about doing that? And how will you be able to estimate the value of A and B? Okay, so if your concept of linear law is very direct, you will realize that, of course, you need to do a linearization first. And the linearization has to be done in such a way that you isolate the constant in the gradient and intercept. So it's a very simple idea, but some have difficulty sinking this into the head. So if this idea is very clear, you realize that in this case, you just need to divide V on both sides. From the formula, you divide V on both sides. You've got a very clear case of Y equal to mx plus G. So this will be the capital Y, this will be the X, and the gradient will be incorporated. A will be incorporated in the gradient, then B will be incorporated in the intercept. So you will need to explain. The explanation is very clean. You just have to explain what is the axis that you are plotting. So you will be plotting the big Y will be D over V, the big X will be V. So our language of explaining this will be, we will always plot the vertical against the horizontal. So my description is just very clear cut. I'll be plotting this against this, D over V against V. And then, so this already explained how you create a straight line to represent the formula. And then from the straight line, how are you going to find the value of A? So you need to explain that the value of A will be obtained from the gradient of the line. And the value of B will be obtained from the y-intercept of the line. Okay, I think I should change this. It's the y-intercept. So essentially, you will get a straight line. The feature about a straight line will be the intercept and the gradient. So with these two features, we will use it to find the two unknown. Technically, that is the big idea for linear law. It's just that the linearization seems to get people confused. But otherwise, I just want to flatten any formula. And then I use the gradient to solve for unknown. I use the intercept to solve for unknown. So that's the whole big idea. So the second one is asking us to find some values. So the second part here, they talk about a tiger population. They give you the year and the number of tiger that they recorded. Okay, so we are modeling a tiger population. So this model is trying to model the number of tigers. So this formula is modeling the tiger. So like population of tiger means how many tigers are there. And then with respect to the time. Okay, in this case, they talk about decade. So they talk about decade. So the time range t equal to 1 means the decade of this. So every 10 years is one decade. So t is not the number of years, it's like which decade that we are talking about. Okay, so anyway, in part 1, we are supposed to draw a straight line to show that the model is reasonable. So you need to decide what straight line you're going to do. So essentially, you need to repeat the process that you have done in part A. But in this case, it's not as direct as just divide by B because it's an exponential function. Exponential function usually require you to log both sides or log both sides. So in this case, I'm introducing log both sides. You can do a log both sides also. It doesn't matter. Okay, you can do a ln both sides or lg both sides. So I'm doing a lg both sides. After you do the lg both sides, don't forget that this is like a product. It's like a product. So it's like a multiplication. So you got to split into log plus log before you can bring down the power. So some common mistake will be some people, they will straight away bring down the power and then they will say that they kind of got stuck. Okay, so this one is wrong. You do not do that because the power belongs to B. So essentially it's like this. So the power T only belongs to B. So you should split out first, let it become a log plus log. Then you bring down the power. Okay, subsequently, the feature will be what is your capital letter Y, what's your capital letter X. And you will be using gradient to find LGB. And you will be using the intercept to find LGA. So you will need to plot out a new table. So using the original table, make sure you go and log all these numbers so that you get a new table. So plot out the new table with whatever scale that you have. Okay, so we just need to plot out. Okay, in this question, you are not asked to find the value of A and B. So strangely, this question never asks you to find A and B. But if you need to find your A and B, you will need to take 2 points. So you will need to take 2 points. I think this one is I think this one is a 3.2. Yeah. So you get 2 points. Something that's easy for you to read. Okay, so you get 2 points. Something that's easy for you to read. Okay, get 2 nice points. Calculate the gradient. And whatever your gradient, that will be your LGB. And then B will be 10 to the power of whatever number that you have. And similarly, LGA will be the intercept. So the intercept is 3.2. So LGA will be 3.2. A will be 10 to the power 3.2. So if the question require you to find A and B, that's how you find it. But in this question, it's not asked. So I don't need to find the value of A and B. However, I need to answer the estimate the number of tiger in the decade. So in this decade, T is equal to 5. So you make sure you have extended the straight line long enough to be able to read this value. And this value is not the direct population yet. This 1.8 is your ln n. So you need to equate 1.85 to ln n. Then from there, you use your logarithm to calculate the number of tigers. So if you didn't use the LG like I'm using, if you use the LN, you will also get a number that's close to 71, maybe 72, 73, 74. So somewhere there. So that is the number of tiger that we are expecting in the decade according to this formula. Okay, so they can give you any numbers. Okay, then this one will be a logic explanation. So give a reason why this model may not be accurate in the later decades. That means as the time go by, why is it not feasible? So the constraint lies with the constraint of the model. Because in this case, right, we got a log n. We got a log n. And log n is supposed to be defined when n is, that means in order for this model to be okay, my n has always needs to be always positive. So because the model contains log n, so if I want the model to be accurate, that means right, n will always be positive. So the model, this formula is trying to tell you that, oh, n will always be positive. Okay, so that's why the implication is, according to the model, n will never be zero. Because of the logarithm that's involved, okay, the model is suggesting that n will never be zero. However, in real life, we know that the number of tiger can reach zero. At the point where the number of tiger reach zero, that's what we call extinction. There's no more of this species anymore. So the model is saying that, right, n will never be zero because it will always be positive so that our log can be defined. However, in real life, it's not true. That's why this model, right, may not apply in the later part. Okay, that means in the later part where there's a chance that it becomes zero, the model actually suggests that it will not become zero. So that's the limitation of the model. If let's say you really couldn't come up with this explanation, not to worry, it's only 1 mark. Okay. So anyway, it's a linear law that doesn't ask you to find the constant, but you are required to know how do you find the constant through the gradient and intercept. Okay.